Greetings and salutations. In this video, we're going to use OpenOffice to learn how to model a stock portfolio or retirement account. I'm using OpenOffice because we may have access to Microsoft Excel and the whole entire Office package through Microsoft at work or at school. But for personal use, we'd have to purchase it. I'm making this video so that way, no matter who you are, no matter where you are, you can do this even if you don't have Microsoft Office and or don't want to pay for it. So OpenOffice is an alternative to Microsoft Office. The equivalent to Excel is called OpenOffice Calc. I'll go ahead and provide you with links to getting OpenOffice. It's completely free. It does the exact same thing that Excel does with a few minor differences. One of the big differences we'll actually see in this video. For the most part, the functions that I do are the same as the ones in Excel. The only difference is instead of semicolons that I use here, you're going to use commas. And I'll remind us of that as we go along in this video. Now, what I want to do is I want to predict how much money I'm going to have after some time has passed. Here's what I'm going to do. I'm going to deposit $2,000. So I've made a cell here, cell B1, deposit $2,000. All right, I'm going to do that frequency per year. I'm going to call that 4 times per year. That's essentially K in the traditional finance formulas. So my K is equal to 4. I'm compounding 4 times per year. That's quarterly. Now, annual market average. I'm setting this as 10% for this example, but you can make this whatever you want. And that's why I have this spreadsheet set up this way. You can make it 12% if you wanted to. You can make it 5%. You can make it whatever you want. And everything in this simulation, everything in this model that we do is going to change. For our purposes, I'll call that 10%. So what do I mean by unit market average? So this is what percentage the stock market changes per unit. And my unit is a quarter. Okay, my unit is 1 quarter, which is 4 times per year. The question is, what does the stock market do every quarter if it increases 10% every single year? The answer is not 10 divided by 4. That would be 2.5. Remember, that's not how exponential things grow and shrink. So you may recognize this top formula right here as the effective interest rate. What we have in this spreadsheet is 10%. That's the effective interest rate right here. We know that after a whole entire year has passed, after whatever compounding or whatever else has happened, we have reached an effective interest rate of 10%. What we want to know is how much does it change each quarter? And that's R divided by 4. That's 10%. Well, actually, it's not 10%. It's some unknown value, some annual interest rate divided by 4. My 10% is my effective interest rate. So I need to use some algebra skills to solve for R over K. So how do I do that? First, I'm going to add 1 to both sides. So add this 1 over. I get the effective interest rate plus 1 equal to this mess right here. Now I want to undo this power of K. How do you undo powers? You take their corresponding roots. And so if it's the K power, I'm going to raise both sides to the 1 over K power. Why do you do that? Well, when you multiply powers by powers, when you raise powers to powers, you multiply those powers. K times 1 over K is K divided by K, and K divided by K, anything divided by itself is 1, as long as that something is not 0. So this is the kth root I'm computing. If this were squared, I take the square root. If K was 3, I would take the cube root. Well, in general, K is whatever it is, and so I'm going to take the kth root. And so what I get is the effective interest rate plus 1 to the 1 over K power equals 1 plus R over K. And it's very simple now to just subtract this 1 over, and I've just solved for the quantity R over K. So that's what I've done in this cell right here. I've done 1 plus C3, which is my 10%. So I've clicked on 10%, raised to the 1 over K power. K is what is sitting inside of cell C2, and then minus 1. 2.41% every single quarter turns out to be 10% over the entire year. And then finally, for standard deviation, I'm just going to make up a number, 5.2%. We'll talk about that in a little bit. If you've ever studied some sort of finance future value formula, we can predict exactly how much money this will be if the 10% never changes. And we know that the stock market does change quite a bit. That's the point of this video. That's the point of this simulation. But if we deposit $2,000 every single quarter, so 4 times a year, and let's do this for 40 years, the interest rate never changes and it always stays at 10%. Rather, 2.41% every single quarter. So remember, that's R over K, this 2.41%. We have a formula that computes the future value. And that's the future value formula that we study, right? So payment, this is 2,000. R divided by K, this was 2.41%. Now for illustrative purposes, I'm going to assume that time is 40. So for example, you start saving when you're 20 and you stop saving when you're 60. That's 40 years. K is equal to 4 minus 1, all divided by R over K. This whole thing right here is your future value. We know everything on the right-hand side here. So we could plug all this in and find the future value of this situation. How much money would we have after 40 years? Microsoft Excel and OpenOffice actually have a function that does that. It's called FV for future value. So we can tell Excel and or OpenOffice exactly what we want to do. These functions are identical in OpenOffice and Excel. The only difference is I use semicolons in OpenOffice. You would use commas in Excel. So I tell whatever program equals FV for future value. I need to tell it what the interest rate is per unit. And so I've selected C5 here. That's my 2.41%. I'm not going to select 10% because it doesn't grow 10% every quarter. It grows 10% every year. That winds up being 2.41%. So that's my per unit interest rate. I have 160 here because I just know that I'm going to do this for 40 years. So 4 times a year multiplied by 40 years. 4 times 40 is 160. And then C1 is how much I deposit. And this formula just happens to take a negative out in front of how much you deposit. The last 2 slots are for present value and type. Don't worry about that. We're not going to worry about those. And we're just going to plug in zeros for those. We'll hit enter. And so if the stock market never changed and you always got 10% every single year, or 2.41% every single quarter, that would wind up being $3.67 million. Okay, now here's the thing. We know that the stock market changes. We're not always going to get 10%. We're not even going to get a positive percent change. Sometimes the stock market goes up, sometimes it goes down. How can we use Excel and OpenOffice to simulate that? If you're following along with me, I strongly suggest that you try to keep things as identical to how I have them here in terms of the layout of your spreadsheet. All right, what do I mean by that? I'm going to put sim here. Don't worry about what that means yet. We'll talk about that in a bit, but I'm going to put a 1 right underneath sim. I'm going to say quarter. This is what quarter I'm talking about. The market change for that particular quarter. How much did the stock market go up and down? How much is my account value worth? Contribution, gains and loss. We'll worry about those at the end of our simulation. So let's talk about quarter 0. I'm going to put a market change. Now, it's 2.41% on average. So if you've ever taken stats, if you've ever taken probability, you've probably seen some sort of bell curve. The peak, the highest point of that bell curve, is at the average. And so I want most of my simulations to be close to 2.41%. And the standard deviation is how wide or how narrow that bell curve is. So a big standard deviation means that your data is very spread out. A small standard deviation means that your data is very, very clustered together, very, very close to the average, very close to 2.41%. So I just made the standard deviation of 5.2% up off the top of my head. It just happens to look nice for our purposes, and it's probably somewhat realistic, okay? But we can change it if we need to. So we can tell Excel to randomly give us a number that's close to 2.41 subject to this spread, subject to the standard deviation of 5.2%. So the function that Excel and OpenOffice use is norm.inv for inverse. Again, these are identical formulas. OpenOffice uses semicolons. Excel is going to use commas. So the first input is what type of number I want. And I'm telling both programs I want a random number. Okay, RAND with open parentheses. Rand, open parentheses, generates a random number between 0 and 1. I want to tell Excel the average, the mean, or the average is 2.41%, or whatever's sitting in cell C5. And so I'm going to put dollar signs before the C and before the 5. What those dollar signs do is they hold that constant. No matter where I click and drag this formula, it's always going to refer to cell C5. I always want my average to be 2.41%. The same thing for the standard deviation. I always want my standard deviation to be 5.2%. That is sitting in cell C6. And so I put dollar signs in front of the C, in front of the 6, letting Excel and or OpenOffice know that I always want to reference that right there. So I hit enter. And now you'll notice if I go to a blank cell and I hit just a random thing, what I'm actually typing is F9. So I'm in a blank cell and I'm typing F9. F9, what it does is anything random on your spreadsheet is just going to regenerate a different random number. Because that's what random is, right? It's just something different each and every time. That's how I get market change. Now for account value, I'm going to start off with $2,000. The big assumption here is that at quarter 0, meaning initially, my market change is going to do whatever it's doing. And then at the very end of that quarter, I'm going to plop in $2,000. Now, I did not type 2,000 in here. In this cell in D12, I said equal to C1 because that's what my constant deposit amount is going to be. So I'm going to tell Excel and or open office. D12 is going to be whatever is in cell C1, because if I change this to $1,000, I just want to change it up here in the upper left and have it change down here automatically. And I just want to do that automatically. So what I have up here is sort of like a little control panel. It takes values, and really the only values that I mess with are these three right here, and it's going to change the entire simulation. So let's go back to 2000 right here. The first quarter has passed. I missed out on this drop of 4.65%, which is good. I plop in $2,000, and now what's going to happen? This $2,000 is going to grow by 4.79%. So I'm going to delete what's in this cell right here and show you what I'm doing. So I'm going to say equal. Now it's changed to 6.13%. I'm going to take whatever was before it, whatever the account value was before. So click on that cell D12, multiply with a little star, open parentheses, 1 plus my market change right here, cell C13, close parentheses. Okay, now I'm going to hit enter, and these numbers are going to change because they're random. So let's look at what happened here. I deposited $2,000. In the course of one quarter, that has grown by 0.45%. So I have my original $2,000, and then 0.45% of 2,000 is $9.07. So that's how I get this D12 multiplied by 1 plus that little tiny bit of interest that I just got. But remember, every single quarter, I'm going to deposit this $2,000. And so to that, I will add, and then click on cell C1. And since I always want it to be that cell C1, I'm going to put a $sign in front of the C, a $sign in front of the 1, and hit enter. Now these are new numbers that have been generated. So let's look at what's going on here. I miss out on this drop of 1.25%. Good. I deposit $2,000. A whole quarter goes by, 3 months goes by, and I get 3.51%. I add 3.51% to $2,000, and then I add another $2,000. And now this is the game that's going to happen. I can do quarter 2, quarter 3, quarter 4, quarter 5. So what I have here for 1 is the 0. I clicked on cell B12 plus 1. And we'll see why, because what I can do now is I can highlight these three, let go of my mouse, click on this little dot in the bottom right and drag it down, and it's going to autofill this formula in for me. Now let's look at what we have here. I deposit $2,000. It grows by 13.04%. That's a great quarter right there. And now I have my original $2,000 plus 13%, which is $260, plus another $2,000 that I just deposited. So we can see that when it goes up plus another $2,000. But let's look right here. It's gone down by 5.14%. Now the reason why my value still went up is because I still deposited an extra $2,000. But this $14,770 that was in the bank account before dropped by 5.14%, and then I add an extra $2,000. If I click on an empty cell and I hit F9, those numbers change. Click on an empty cell, hit F9. I can keep hitting F9, and I keep getting different simulations. Now before I move on, I want to look at contribution. So my contribution is, first it starts off as $2,000. So I'm going to say equals whatever number sitting up there. And now to that I will say equals, and the cell right below it, whatever was before it. So click on E12 plus, and now I'm going to click up here to cell C1, because we know that every single quarter I'm going to deposit and contribute $2,000. Now again, I don't want that value to change, and so I'm going to put a $sign in front of C, a $sign in front of 1, hit enter. So now if I click and drag this down, we can see how much I've contributed. For example, after 17 quarters, I have contributed $36,000, because I'm always adding 2,000, adding 2,000, adding 2,000. But my account has grown to 51,828 and some change. So we can compute the gains and losses. I can say equals my account value minus the contribution. And this will compute how much money I've made in the stock market during the course of these 17 quarters. Now look at this. It's actually gone down. Okay, and what's nice is at least Open Office indicates that if it's money and if it's negative, they turn it red, because red's not good. We've lost $1,600, right? We'd be better off just putting our money under our mattress, and we'd have $22,000 because our account value is only worth $20,000 and some change. So that's not good. We're not going to save up for just 17 quarters. That would be a little over 4 years. When you invest in the stock market like this, you usually want to do it long term. So what I'm going to do is I'm going to highlight this entire row, and I'm going to click and drag this down until my quarter winds up being 160. That would be 40 years. So I'm going to click on this little box in the bottom right hand corner and click and drag this down. If I go over, that's okay. Oh, I didn't go far enough. I need to go a little bit farther. And there's 160, so I will delete everything below it. Widen column F. And we can see that after 160 quarters or 40 years, I make a little over $1 million in gains because my account value is worth $1.4 million. We've contributed $322,000. That's money out of pocket that we've plopped in here. But it has grown to $1.4 million, means that we have gained over $1 million by doing that. And if I scroll up here, I'm going to guess that at some point, hey, look at that. Initially, it was negative. And that tends to happen when you invest money is the very early days of your investment, it's going to go up and down, up and down, up and down. But if you do it long term, at least in this simulation, you're going to wind up making $1 million after 40 years. I'm going to click on a blank cell. I'm going to hit F9. And look at that. I made $7.8 million in gains because I still deposited only $322,000, but that grew to $8.2 million, meaning I walk away with an extra $7.9 million in the bank. But again, that's that simulation. Now let's scroll back up here. There was some red here, right? After a few years, we were down a bit. And this is scary when you're first investing and you see your money, your hard-earned money, you put in $20,000 and you're not even making interest. You're not even making 1% interest that you would get in a very moderate savings account. You are actually losing money. You've lost over $1,000. But if you keep at it and you keep depositing 2,000, 2,000, 2,000, 2,000, it never becomes red again. Matter of fact, you wind up walking away with $8 million. Now, again, that's that simulation. Click on an empty cell, hit F9, 1.7 million in gains, 2.5 million in gains, 2 million in gains. I'm going to keep hitting this, and I'm going to guess it's never turning red at the very end. But what we can also see is that there's a lot of variability here. 1.4, 2.2, 5.3. Again, I'm looking at this cell right here. I'm looking at the total gains and losses. 2.3, 2.8, 2.0, 5.2, 9.4. So there's a lot of variability in here. So what we would like to know is, if this is how the stock market works, what are the odds that I'm going to make money? What are the odds that I'm actually going to come out ahead? Now, before I move on, this is actually interesting. After 42 quarters, which is a little under 11 years, we've still lost money. Look at that. We've deposited $86,000 and our account is only worth $85,000. We've lost money overall. That's not even keeping up with inflation. So that's not good. But that's after only 42 quarters, roughly between 10 and 11 years. If we scroll down, look at this. We still wind up making $9 million in that same simulation. So yeah, the red appears pretty far down the list here, but if you stick with it, this simulation would show that you would get $9.5 million in gains. What does this 3.67 million have to do with anything now? This is sort of an average. Okay, so we use this in the future value formula to say if we invested $2,000 every quarter, 4 quarters a year for 40 years at 10% interest, we would get this. And these numbers bounce around $3.67 million. So if I kept doing this over and over and over and over again, you would see that sometimes it's below 3.67 million. Sometimes it's, actually, we're looking at the future value here. So that 3.67 million keeps bouncing around between here. So the question is, how can I just get a bunch of simulations all in one? Now this is where Excel and OpenOffice really diverge in terms of their usefulness. I'm going to say equals. I'm going to scroll all the way down here, and I'm going to click on this cell, the 6.1 million. It's probably a different number for you if you're following along, but it's just what is my account value after 160 quarters? And I'm going to hit enter. It just basically saves me the hassle of having to scroll all the way down here. Oh, 4.072. Well, it's $4.072 million up here. And I also want to know what is my gains and losses at the very end. So I'm going to scroll all the way down here, click on that, hit enter. And I might even put these in boldface type, like so. All right. And anytime you make a change to your spreadsheet, all your random numbers are going to change. So I just made that boldface type and it changed my numbers for me. Now I can see all the changes. I can see the account values and the gains and losses all the time now, just by hitting F9 in a blank cell. What do I mean by sim? I mean simulation 1. I would like to simulate this many, 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 many times because I don't want to have to sit here and keep hitting F9 and refreshing these numbers. If I simulate this a bunch of times, what are the odds? What is the probability I'm going to make over $4 million or I'm going to make over $10 million? Again, this is where Excel and OpenOffice really diverge in terms of their usefulness. I sat here for a couple hours trying to figure out a way to do this in OpenOffice that I did in Excel, and I could never figure it out. If you know how to do this, if you can figure this out in OpenOffice and be the first person to tell me, I would be forever grateful, and I don't know what I would do. I would just be very grateful, and I would give you a high five, and if you're in my class, maybe even some bonus points. So I'm going to do it the not so nice way in OpenOffice. And so I want to tell OpenOffice, hey, make a bunch of these simulations. This right here, all the way to 160, this is one simulation. Okay, I just edited out a lot of frustration, and I learned a lesson the hard way here. And I'm going to have you make a quick change. So for a quarter, when I say 0, don't just type in 0. Let's put a 0 in the very, very upper left in cell A1 or wherever you like, and reference it with a $sign. So you always want that to stay 0. What was happening was I was trying to autofill my formulas, and it was always advancing this by a 1. And it was very, so what it was doing is it was extending how far out into the future we go every time I ran a simulation. What I really have now is one simulation of 40 years. And again, hit F9, and we just get a bunch of different values. We want to run many simulations of this. This is what's called a Monte Carlo simulation. Essentially, we're rolling the dice many, many times and looking at what is the grand total. If I run this experiment 10 times, 100 times, 1,000 times, 1,000,000 times, do I sort of center in at something? Is there some sort of probability that I can look at and say, there's a pretty good chance I'm going to make at least $5 million or whatever? I'm going to highlight sim for my simulation, and I'm going to highlight everything that I have here all the way down to the 160. I'm going to release my clicker. Now, I'm working on a PC, so what I'm about to do is called Shift. I'm going to hold down Shift, and then I'm going to hold down Page Down. If you're on a Mac, I have no idea what that command is. So Shift, Page Down, I'm going to hold those both down, and I'm just going to let this go down for a long time because I want to run many, many, many simulations of this. So I might go down to, I don't know, row 20,000 maybe. And now what I'm going to do is edit. I'm going to go to fill. I'm going to go to series. And I'm going to tell Excel and or OpenOffice, hey, you're smart. Figure out what I'm doing here. So I want to go down. Series type autofill. I'm going to let Excel and OpenOffice figure out what I'm doing. I'm going to click OK. And now this last simulation may not end at 160, and that's fine. So I'll just erase this last one. This wasn't complete, so I'll just make that go away, delete all. Now what I have here, if I look back at my last simulation, this was counting how many simulations I had. I now have 129 simulations of the same thing. This simulation ended at $5.3 million. This simulation ended at $1.7 million. And so I don't have to keep hitting F9, 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 F9. I can look at the different simulations. And what I'm going to do is as follows. I'm going to put sim for simulation. Simulation 1, Simulation 2, Simulation 3, and we know where we ended. We ended at 129. At least I did. You may have had something different. So I know that I have 129 simulations of this. So I'm going to go to 129, and right there. And I'm going to tell OpenOffice to look for what is just to the right of my simulation number. So notice every single one of these simulations has this little counter that tells you what simulation you're looking at. And then 1, 2, 3 rows over, it's the account value. So I'm going to put account value, and I'm going to put G/L for gains or loss. So here's how I'm going to do this. I'm going to say EV lookup. If you're doing this in Excel, it's the exact same thing, but with commas In OpenOffice, it's semicolons once again. But what do I want to look for? I want to look for the number 1. So I'm going to click on 1, semicolon or comma, array. So I want to look at every single thing that I copied and pasted. So I want to look at this entire array. So I'm going to click all of this down here. And I'm just going to hold and drag this down for a long, long time. Might even shift down it because that's just going to highlight everything that I have, and just can sit here, and it goes a little bit quicker than using my mouse. Shift page down, and I go to the very end, right about there. And it doesn't have to be perfect even. So it's telling Excel, all right, or OpenOffice, look in all of these cells for the number 1, and then I'm going to put a semicolon or comma if I'm in Excel. What index? And so what index means is what column are you looking at? Not in column 1, not in column 2, not in column 3, but I am looking in column 4. So I put a 4 right here. Again, I just had index, and what index is relative to this thing right here. This is an index 1, which is where I'm looking for the number 1. I want to look not in column 2, not in column 3, but whatever is in column 4, report that number. And then semicolon, sort order, we'll just put false. Don't worry about what that is. And I'm going to hit enter. Excel and or OpenOffice doesn't know that I want this to be money, so I'm going to highlight this entire column by clicking on I, and click on the little money sign. And I don't even care about cents anymore because I'm talking about millions of dollars. So I might even just get rid of all of my decimal places by clicking this X with the decimal points. Now what this is doing is it is reporting how much money I had right here for simulation 1. I want to do the same thing for simulation 2, simulation 3, simulation 4, and I don't want to have to keep clicking and dragging all the way down this. I'm going to click and drag this formula, and it's going to look at the number 2, and then search this entire array that we have here of values and look for the value 2 in column A, and then value 3, simulation 4, simulation 5. Now the one thing I want to do before we move on is I want to put dollar signs around A13 and the F and the 21,000 whatever, because I want it to always look in that same array, okay, in that same big gigantic thing that we highlighted. So I'm going to enter, and now I'm going to do the same thing for gains and losses. I'm going to say equals VLOOKUP, make sure you spell it correctly, look up, open parenthesis. What am I looking for? I'm looking for the number 1 because that's my simulation. Comma or semicolon. I'm looking in this gigantic array. Now it's the same array as what I'm looking for in account value. So I think I remember that that's from A13 all the way to F. It was like 21,000. Let's just put 999. It actually doesn't matter because even if you overshoot it, it's still going to find only that value that you're looking for. And now I'm not looking in index 1, 2, 3, or 4. I'm looking in 5, 6. So I put a 6 right there. And then semicolon, don't worry about sort order. I'm going to put false, hit enter. Once again, I want this to be currency. I don't care about decimal places anymore because it's a lot of money. And so now what I have is a report of what is in this column. And so I want to do this for simulation 2, simulation 3, simulation 4. So I'm going to highlight these 2 entries. I'm going to click on this little box in the bottom right, and I'm going to have it fill out all these simulations for me, 129 of them. Now this is where it's going to hang up. It's probably going to freeze for a little bit, but that's okay. And now what we can see is all the different simulations, 129 of them, that report at the end of 160 quarters, 40 years, how much is your account balance worth and how much have you gained or lost. And so now we can see, without even looking at a bunch of different random numbers, the variability in these ending values, all the possibilities that we have. Click on an empty cell, hit F9. It's going to think for a bit, and then it regenerates those values. So I wonder what the average of all those account values are. So I'm going to put ACCT-AVG for account average. I wonder what it looks like when I look at the average of everything in column I. So Excel can compute averages. I'm going to say equals average. And in Excel or OpenOffice, it's the same thing. I'm just going to click and drag all the way down here in parentheses and hit enter. It's going to think for a little bit because I have a lot of stuff going on here. But hey, look at that. My account average is $3.6 million. And what was predicted here was about $3.6 million, right? 3.7. Click on an empty cell, hit F9. It's going to think about it for a bit. And this number didn't change much. 3.52 million. Hit F9. Hey, that number didn't change much. 3.4 million now. Hit F9 again. Hey, that number didn't change much again. So yes, there is a lot of variability in column I. There's all sorts of possibilities here. As a matter of fact, look at this one right here. This is not good. You've deposited a bunch of money, but your account value is not even worth $1 million, which means over the course of 40 years, you only gained $427,000 in interest. Right? That's not ideal because other cases, you make $3.9 million, you make $8.4 million, $7.4 million. So there's a lot of possibilities here. But this is what's called the law of large numbers. Is it all averages out to something pretty close to what we expected. Again, I'm going to hit F9 in the blank cell. And again, ooh, look at that. I average $4.2 million, right? So this average is not subject to being constant. It still has variability, but not as much variability as I had in the account values. And I can do the same thing for the gains and loss average. And now my computer is going to really start hanging up every time I enter a new command because it's doing all these simulations. It's doing 129 simulations of 160 things, and every time it's generating random numbers for each and every one of them. So my computer is going to start to lag. I'm going to guess yours is too. But I'm going to say average. I'm going to average everything in column J, like so. Close parentheses right here, hit enter, and we can find out what the average gains or losses is. And again, I'm going to get rid of my decimal points there. We're good. Oh, and now it doesn't know that it's money anymore, so I'm going to make it money, get rid of my decimal places. And again, you can really see this thing starting to lag. But the account average is very, very, very close to what we predicted. So that's what I mean in class when I say your future value is $3.7 million. Some people would ask, but the stock market changes. It's not always 10%. You're right. And that's what we've just simulated right here. And we can look at all the different possible outcomes and the frequency and the probability that we get them. As a matter of fact, look at this one right here, 66. Execute order 66. We only make $500,000, or we don't make that. That's the account value. We had to put in $322,000, meaning we only make a profit of $200,000. That is not good over the course of 40 years. Meanwhile, in a different scenario, we could make almost $9 million. Another thing that I want to show you before we end this video is what about, we're going to talk about the 1 percentile, the 5 percentile, and again, this is really starting to lag here, and the 25th percentile. So what do I mean by that? I want to know what's the probability, what are the odds that I make a bunch of money or I lose a bunch of money, all right? So for example, we don't like these where we only wind up making $575,000. We want to know what's the odds that that happens. I'm going to say equals percentile, and percentile takes in two different things. And in Excel, it's the same exact command, only there's a comma separating these things. So I want to look at all the gains and losses. So that's what I mean by data here. So gains and losses. Look at all these things, and I'm going to put semicolon in OpenOffice, comma in Excel, alpha. And what alpha is the percentage. So I'm going to click on 1%, close that, hit enter. And I'm going to do the same thing, but I'm going to put $signs in front of J, in front of 2, in front of J, in front of 130, because I want to look at the same data set, but I want to look at the 5 percentile and the 25 percentile. So click and drag that formula down, and I'm going to make this, I'm going to make this money. I'm going to get rid of my decimal places. Remember, we're looking at gains and losses. We're looking at column J, gains and losses. What does this tell me? According to 129 simulations, 1% of the time, I'm going to make $685,000 or less. And that's profit. Remember, we're looking at column J, profit. So what this is telling me is 99% of the time, I'm going to make at least $685,000. 5% of the time, I'm going to make $1.2 million or less, which means that 95% of the time, I'm going to make more than that. Now, 129 isn't a very good number of simulations. I mean, usually you want to do 1,000, 10,000 simulations of this. This is just getting a feel for what we're doing. On average, and that's the thing, on average, we're going to make $3.2 million. Now, again, if I come out here and I hit F9, it's going to redo everything. But these numbers don't change a whole heck of a lot in column M rate. The gains and loss average is $3.2 million. Hit F9 again. $3.5 million. Doesn't change a whole bunch. This average, the average of the account value is staying very, very close to what we predicted with the future value formula way back in deterministic land when we didn't even know what a random variable was. Now what we're doing is we're looking and verifying that that's an average when you make 10% a year, depending on what the stock market's doing. Sometimes it goes up, sometimes it goes down. But what we can do with this Monte Carlo simulation, what we can do with this randomness is say, you know what, 99% of the time, you're going to walk away with over $764,000. And again, these numbers change as well. But to get a better, more accurate picture, what you want to do is not do 129 simulations. You want to do 1,000 simulations. But this is giving you a ballpark idea. That's the big takeaway from this is if I want to make $1 million in profit, if I want to invest my money and after 40 years of saving up, retire with $1 million in profit, there's a 95% chance that that's going to happen. It's not a guarantee. It's not a guarantee. 95% is not a guarantee. What it's saying is 95% of the time you're going to make over $1.078 million, but 5% of the time you're going to make under that. As a matter of fact, 1% of the time you're going to make under $784,000. And if we look at these simulations, here's one of them right here. Right, we've made $500,000 in profit. That's a very unfortunate circumstance. That's a very unfortunate situation. But a lot of these, we're making 3.2 million, we're making 2.8 million, we're making $6.2 million. So this is an introduction to Monte Carlo simulation. The way that you do this in Excel is pretty much the same thing, only we don't have to do all of this in Excel. We don't have to click and drag all of this down. It's a little bit quicker in Excel, but you're also going to have the same problem of your computer lagging because Excel is doing hundreds, if not thousands, of simulations of something that already generates hundreds, if not thousands, of random numbers. Hopefully you learned something from this. I appreciate you watching, and I might even do a follow-up with more intricate, involved finance models later.